Good morning, guys. This should be Tuesday, March 24th. We're going to start by talking about how to prove that something is a parallelogram in the coordinate plane. So coordinate plane is when we get coordinates, so an x and y coordinate. So I'm hoping today might be a little bit more interesting because it's not just going to be like solving linear equations the whole time. It's going to be actually we're using these methods to prove and justify our reasoning and really getting into more geometry-based things instead of algebra. There will be some minor algebra things, but this is more of like the big bulk of geometry. So there's three methods that we're going to use. Method 1, and it's going to be very easy to tell what each of these methods are, and even whenever you're doing like problems, it's going to tell you exactly which method to use. So taking a minute, pausing, getting this stuff down, like splitting up method by method, use this, like that will be really helpful when you're going through problems and just later on quizzes. Like I said, the rigor of NTI for geometry should not be as hard as it was in class. I'm trying to make this still good geometry, but you guys need to use your notes whenever you're taking quizzes or turning stuff in. Like, I'm not making these videos just to become famous on YouTube. Like, that's not my goal. My goal is to teach you some geometry still, right? So, I'll get off my soap opera there. For the first method, we're going to prove both pairs of opposite sides are congruent. So this was one of those parallelogram properties that there's two opposite sides are congruent. So we would say that if side AB is congruent to CD, so here's AB and here's CD, and AD is congruent, that's congruent to side BC, then ABCD is a parallelogram. So this calling ABCD a parallelogram, it's the same thing as when we said like ABC is a triangle, we just go in order, A, B, C, D. So we just always have to use 4 letters for a parallelogram. So whenever we're trying to say that two pairs of opposite sides are congruent, if they're congruent, that means they're the same measurement, right? So when we talk about finding measurements and we're given coordinates, we're going to use something that we did a long time ago, but the distance formula. And if you don't remember the distance formula, it's all good because I still have it. Distance formula, so D equals the square root, and then you're going to take x1 minus x2 squared plus y1 minus y2 squared. Okay? And if you can't read my handwriting very well, if you just Google what's the distance formula, it should pop up pretty easy for you. But again, it's the square root of x1 minus x2 squared plus y1 minus y2 squared. All right? So then we're going to do, so that's method 1. Method 2 is we're going to prove both pairs of opposite sides are parallel. So when we think about two sides being parallel, there's something specific with parallel lines. Parallel lines have the same slope. Hopefully you said slope. So whenever we're using this method, we're going to use the slope formula. So slope formula is where we calculate that m, and m equals y2 minus y1 all over x2 minus x1. It's that rise over run formula. And I think most of my classes we had that discussion about how you could have y1 minus y2 over x1 minus x2. And we got into a little bit of a heated debate in some classes, but either way you look at it, it should be your change in y over your change in x. So if we're proving both pairs of opposite sides are parallel, then we want to say if AB is parallel, so parallel are the two lines that look like parallel lines, to DC, and AD is parallel to BC. So whenever you talk about parallel lines, instead of doing the tick marks to show congruency, parallel lines, we use the arrows. So just like that. So when you're finding, or you're proving that two of the opposite sides are parallel, you're going to use slope, okay? And that slope has to be the same. If you get something different for both of your lines, then that means they're not parallel and that they're actually going to intersect at some point if the lines were truly to go on forever and ever. The last method is to prove one pair of opposite sides are congruent and parallel. So we're going to have a mixture of method 1 and 2. So first we're going to say if AB is congruent to CD, and then we would say AB is parallel to CD. So it's like mixing the two, but instead of using both pairs, like we are in method 1 and method 2, we're only talking about one pair. So we're only looking at AB and CD being congruent but also parallel to each other. So for this one, we're going to have to use both formulas. So distance formula and slope formula. All right, so if you do not have those notes down, pause right now, get them all down, and then we're going to move on to some problems. And these problems, if you want, you can actually try to graph them because they are actual coordinates in the coordinate plane, but you don't have to because we can just use these formulas on the side. All right, so I hope you have a calculator ready because a lot of this will be just plugging in numbers into the formulas, which are straight into your calculator. They can be anyway. And so for number 1, I'm going to do it fully with you, and then 2, I'm really just going to start it kind of, and then pause, and then I'll go to the answer so you can just see where I end up, and so you can fully try it on your own and see if you're actually computing things correctly. So for 1, it says determine whether the figure is a parallelogram using the distance formula. So using the distance formula is that first method. And then distance formula is where we take the square root of x1 minus x2 plus y1 minus y2. Oh, and we're squaring these. Hopefully I said that up there. Yep. And so once you plug it into this formula, we're going to see if these actual side lengths are the same thing. I'm actually going to get rid of this so I have more room. So when I talk about this parallelogram, I would have something that hopefully looks like this if it is a parallelogram. So I'd have A, B, C, and D. So I want to show that AB and DC are congruent and AD and BC are congruent, hopefully. So if I start, I want to find the length of, let's do AB first, so AB. So I'm going to take the square root, and AB would be using these coordinates. And remember that your coordinates are always x first, then y. So x for my a would be -7, and then my y would be 4. So if I start plugging this into my formula, I'm going to have -7 minus 1 squared plus 4 minus 2 squared. And I think you can also have this like x2 minus x1 and then y2 minus y1. The order of x and y doesn't matter in the distance formula. So if you want to try it the other way and see if you get the same thing, you can. So once I do -7 minus 1, square that, I would get 64 plus, and then 4 minus 2, square that, I get 4. So square root of 64 plus 4 would be the square root of 68. I'm just going to leave it as a square root of 68 because I don't want to deal with decimals, and I know that's not going to be a pretty number, so I'm just going to leave it as 68. Next, so I have AB. Next I want to find, let's do DC, see if they're actually congruent. So if I start by finding DC, I would have the square root of 9 minus 1 squared plus -8 minus -6. So minus -6 actually turns into +6. It's a double negative. And so then I get 9 minus 1, that's 8 squared. So I get 64 plus, let me use my pointer, -8 plus 6, that would be -2. When you take -2 squared, you're going to keep -2 in the parentheses. Otherwise, you're not going to get the same right thing. So keep -2 in parentheses. And if you square that, you're going to get a +2, which is a lot like what we got up at the top. So this also turns out to be -68. So far, we have shown that AB and DC are actually congruent because square root of 68, square root of 68. So we're good with that, those two sides. The next thing we need to figure out is if the other pair of sides are actually congruent, so AD and BC. So if I look at AD, here's, oh shoot, I don't want that. Here's A, here's D. So I'm going to have AD equals the square root of -7 minus 1 squared plus 4 minus -6, which turns into a +6. So -7 minus 1, that's -8. -8 squared gets 64 again. And then 4 plus 6 is 10. 10 squared is 100, so I get 64 plus 100, which then it turns out to be 164. Okay, so what I'm hoping for is that this segment BC is also 160, the square root of 164, because that would then prove that this is a parallelogram by using the distance formula. So if I use BC, I'm going to have 1 minus 9 squared plus 2 minus -8, which turns into 2 plus 8 squared. Then I would get 1 minus 9, that gives me a -8. -8 squared is 64, off to a good track. And then 2 plus 8, 10. Again, I get 100, so then that works out to be square root of 164. So we have two pairs of congruent sides. That means that yes, this is a parallelogram. Oh, I don't want to use a highlighter. And so we'd say yes, A, B, C, D is a parallelogram. Okay, so my tip for you for doing number 2 is to first try to just draw a picture. You're not using A, B, C, and D again, but make it easy on yourself and just go in order. And then try to figure out, okay, I want to find these two opposite sides should be congruent, and then find the other pair and see if they are congruent. All right, pause here. And then when you have everything done, come back. All right, so for number 2, hopefully you got that PQRS is not a parallelogram. I stopped right after I found PQ and RS because I knew that I had to first show that those two segments were congruent. So since I already showed that they weren't congruent, I didn't even find PS and QR. Because in this method, you have to show that both sides, both pairs of opposite sides are congruent. So since I already proved one is not, I already have enough information to say, no, the whole thing is not a parallelogram. So if you did a little bit extra work, that's fine, but just know that if you're using this method, once you find that one counter example, you have enough information to say no. Okay? So let's go to the back. I believe we're going to do 2 of each of these. So again, I'm going to do number 3 with you, and then you're going to pause and try number 4 on your own. So with these, you're going to determine whether a figure is a parallelogram using the slope formula. So to the right, I'm going to have the slope formula. So m equals y2 minus y1 all over x2 minus x1, my rise over run. So when I'm looking at this parallelogram, I have w, x, y, z, and I want to show that wx is parallel to zy. So let's start there. So when I have wx, if I'm finding the slope of wx, abbreviate this to be mwx. I would have -6 minus -4, so it turns into +4 over 1 minus -7, so +7. And I get -2 over 8, which I could then simplify to -1/4. Okay? Kind of box that in. Now I want to find the slope of zy. So m of zy. Equals z is -12 minus, no news, Twitter, thanks. -12 minus -13, so +13, over 1 minus 5. So -12 plus 13, I would get 1 over 1 minus 5, -4. So that is also -1/4. So far, so good. We have enough to prove those two are parallel. They have the same exact slope. Now I'm going to see if the slope of wz and xy are the same. So m of wz is going to be -4 minus -12, which turns into +12 over -7 minus 1. So -4 plus 12, that would give me 8. And then -7 minus 1 would give me -8. So if I have 8 over -8, that turns into just -1. And then, whoops, I forgot the line. My last slope I'm going to find is the slope of xy. So the slope of xy would be -13 minus -6, so 13 plus 6, all over 5 minus 1. So -13 plus 6, I get -7. And then 5 minus 1 is 4. Those don't look right at all. So since these are not the same thing, that's -7 over 4. Since these are not the same thing, we can't say that they're parallel to each other. They don't have the same slope. So we would have to say no, this is not a parallelogram. WXYZ is not. Okay, so now's your turn to try number 4 with parallelogram EFGH. Number 4, I got yes, this is a parallelogram because I have the slope of EF is congruent to the slope of HG. They're both a third. And then the slope of EH is congruent to the slope of FG. They're both 5/2. So yes, we can conclude this is a parallelogram. All right, then last method, we have to use a combination of both. But instead of doing 2 different pairs, we're only going to look at one set of opposite sides. So we get to choose which one we want. It's completely optional. There's no right or wrong, because no matter which one you choose, if it truly is a parallelogram, they should both work. So I always just look at the first 2 letters, JK, and then go off from there. But it's completely up to you, whatever is easiest for you to visualize. So I have parallelogram JKLM. So I want to show that JK is congruent to LM and also parallel to LM. So first, I'm going to use distance formula to show that they're congruent. So if I find the distance of JK, I'm going to take the square root of -9 minus -5, which turns into +5 squared, plus -2 minus 1 squared. And -9 plus 5 gives me -4. -4 squared is 16. Plus -2 minus 1 is -3. -3 squared is +9. So I get the square root of 16 plus 9, which is also the square root of 25, which I can actually simplify that to just be 5. Okay? Now, I want to make sure that ML is also going to be just 5. So if I look at ML, oops, I can make it smaller. I would have the square root of -3 minus 1 squared plus -7 minus -4, so +4 squared. I'm actually going to have to shift a little bit. So -3 minus 1 is -4, so -4 squared gives me the 16. And then -7 plus 4 would be -3. -3 squared, there's my 9. So I actually end up having the exact same thing as above, which turns into just 5. So far we've shown that the 2 sides are congruent, so now we got to do the parallel part. So I'm going to find the slope of JK, And I'm going to do that by doing 1 minus negative 2, so 1 plus 2, over negative 5 minus negative 9, so plus 9. And I get 3 over 4. Okay, so now I got to find the slope of ML. That is not an L. So the slope of ML would be negative 7 minus negative 4 plus 4, and then negative 3 minus 1. So negative 7 plus 4 is negative 3. Negative 3 minus 1 is negative 4. If I simplify that, the negatives cancel, and so then I'm just left with 3/4, which would mean that my slopes are congruent to each other, and that I've shown that JK is parallel to ML. So we have enough information to say yes, JK LM is a parallelogram. Okay. All right, so hopefully for number 6 you got no, STUV is not a parallelogram. If you found the distance first for ST and UV, if you use these two sides, you would have found right away that they're not congruent. So since you already know that there's one pair of sides that aren't congruent to each other, that means that you have enough to conclude that this is not a parallelogram, because even though we're only using, in method 1 and 2, we're only using one property of a parallelogram, if you find any counterexamples, that's enough to say you cannot have a parallelogram. So hopefully today we got enough practice with this. On Wednesday, you're going to have just 3 problems to turn in, kind of like what you did on Monday. So be ready for that, and hope you guys are doing well and staying safe and healthy, and let me know if you have any questions. All right, bye.